In the diagram, right-angled triangles AED and BFC are constructed inside rectangle ABCD so that F lies on DE. If AE is 21, ED is 72, and BF is 45, what is the length of AB? So first and foremost, let's utilize the fact that these are right triangles to figure out some distances. AE, they tell us, is 21, and ED, they tell us, is 72. So we can easily figure out AD using Pythagoras. AD squared will be 21 squared plus 72 squared. Correct? And that looks like AD will therefore be 75 if you do that math there. So I'll just write 75 up here. All right, anything else that we can figure out? I think so. They give us that BF is 45, that distance right there. And we just figured out that AD was 75, so obviously BC will also be 75 since this is a rectangle. So that will also give us a Pythagorean relationship. We have BF squared plus FC squared is equal to BC squared. And BC is going to be 75 squared. FC is what we will figure out. And BF they give us in the question is 45 squared. So if you do the math here, you'll get FC is equal to 60. So I'll just put that there, 60, and BF they gave us in the question is 45. Okay? And I think that is the first part of the question. Pretty straightforward. Now, where do we want to go from here? At this point, I'm going to draw a perpendicular from the top all the way to the bottom. So that green line is going to be very important for us in this question. And I'm going to label some of these points here. Where it touches BC, I'll call it G, just to be consistent with our letters A, B, C, D, E, F, G. And where it touches AD, I'll call it H. Okay? All right. Now, this is going to be the heart of the question. The first thing, of course, is I want to concentrate on trying to figure out FG, that distance. So from here till here. Now, that can be done pretty quickly, considering the fact that you have this triangle here. And that triangle, the area can be calculated in two ways. The first way, of course, is 1/2 base times height, using 45 as the base and 60 as the height. So that's the first way, 1/2 times 45 times 60. And now another way is to use this as the base and this as the height, FG. So that would be 1/2 base, which is BC, and BC we know already is equal to 75, since that's a rectangle. And then our height is FG. Now these two ways of calculating the triangle's area are equal, right? Because the area is the same, regardless of which way you do it. So this will allow us to figure out FG. And if you do this math, you'll get FG is equal to 36. All right, so I'll put that 36 in there right there. Now I'm going to calculate F to H, that distance right there. If I can do that, then I can add it to my FG, and that will give me the length of AB, which is exactly what they want. Okay, now let's concentrate on FH. FH. Okay, so how do we do FH here? FH, I'm going to have to label a few things here, but fortunately they're not that complicated. This is a right angle right there. Okay? And if this is, say, angle theta, then this would be right here, 90 minus theta. correct? And in a very similar way, if you look at this triangle, just that one, this is also 90 minus theta. So I've got a similar triangle situation here. This triangle right here, which would be, I guess in terms of letters, DFH. DFH triangle is similar to this guy right here. That is what? ADE. ADE. And because they are similar, the ratio of the sides are the same. So here we go. FH, which is this side right here, so that's the side that includes 90 minus theta and 90, would be the same as this one, AE, in terms of the ratio. And that would be equal to the ratio of two other sides. So I'll use, say, HD, which would be the 90 and the theta side. And the 90 and the theta side on the other triangle is this one, ED. So HD over ED. There you go. And I think this should do it. Let's see here. FH, well, that's obviously what we're trying to figure out. AE, do we know the length of that? Yes, we do. It's 21. And then HD, from here to here, do we know the length of that? Actually, we don't. But it's okay. I can figure it out. HD would actually be the same as GC, correct? Since this is a perpendicular right there. And GC I can easily figure out using Pythagoras. It'll basically be GC is equal to 60 squared minus 36 squared, like that. Right? And that gives me GC is equal to 48. So therefore HD is also 48. So HD is 48, and I'll put that there. We're still continuing this relationship. And ED, well, fortunately, they give us that in the question. They give us that in the question stem, actually, 72. All right, we got it. So doing the math here, we get FH is equal to 14. And there you have it. We've got the full distance. They want you to figure out AB, correct? I think I can squeeze it in here. AB is equal to FH plus FG. And both of those we figured out. FH we figured out as 14, and FG we figured out as 36. And therefore 14 plus 36 is 50. So number 25, the answer is A. The top section of an 8 by 6 centimeter rectangular sheet of paper is folded along a straight line so that when the top section lies flat on the bottom section, corner P lies on top of corner R. The length of the crease in centimeters is. Well, perfectly allowable. Take out a piece of paper and make that fold, and you'll be able to see the crease. And then once you have the crease, we can move forward with the question. When you make that crease, it will be something like this. That crease will be approximately something that looks like that. And then you can try it, right? I encourage you to try it. So what we will do is we will work with that. First thing I want to do is draw some horizontal lines. One here and one here, like that. And let's start labeling some things here. It's an 8 by 6, right? So this whole thing is 8 and this whole thing is 6. Now, the distance from here to here, that I don't know, so I'll just call that X. And these were horizontal lines, so this is going to be X. And this is X and that's X also. And therefore, this section in the middle is going to be 8 minus 2X. And yeah, that's pretty much all we have so far. But the reason I told you I encourage you to do this on a piece of paper is that you'll find that when you actually make that fold and have P come and land on R, you'll notice that this segment right here corresponds entirely to this segment from there to there. So if you were to draw, say, a line from this point to this point, you will see it matches entirely to that segment. It's identical. So what that means is that those lengths are the same. So since from here to here is 8 minus x, right? 8 minus x is from here to here. This is also 8 minus x. So I'll just put that in there, 8 minus x. So now we've got two Pythagorean relationships, and off we go. So the first one is this guy right here. That one gives me x squared plus 6 squared is equal to 8 minus x squared. And that's going to be 64 minus 16x plus x squared is x squared plus 36. The x squareds cancel, which is very good. That's 16x, and then 64 minus 36 is 28, and therefore x will be 28 divided by 16, which is 1.75. Okay, pretty good number. Now our next Pythagorean relationship involves this triangle, and the crease is what they want, right? So that is the crease there, so I'll just call it C for crease. That Pythagorean relationship is as follows. It's 6 squared, right? Because from here to here is 6. Plus 8 minus 2x squared is equal to c squared. So substitute x equals 1.75 into this, and we get 36 plus, that's going to be 20.25 when you square it, 8 minus 2x squared. And that's equal to c squared. And this is 56.25 is equal to c squared. And when you take the square root, you get 7.5. So the crease is 7.5, and that means number 22, the answer is C. ABCD is a rectangle with AB equal to 12 and BC equal to 18. Rectangle AEFG is formed by rotating ABCD about A through an angle of 30 degrees. The total area of the shaded regions is closest to. First and foremost, I will let this shaded area here be A, and then this shaded area on the bottom be B, and this unshaded area be C. So first look at A plus C. A plus C is essentially just the rectangle, correct? So that, in terms of an area, since the dimensions are 18 and 12, is 18 times 12. And then if you add to that C plus B, that also represents the area of the rectangle, so 18 times 12 again. And that is going to be 216 plus 216, which is 432. Now, we are not interested in C. We only want A plus B. So therefore, A plus B, if you were to add all these guys together, plus 2C, we just figured out was 432. So the area of the shaded region is just A plus B, which is 432 minus 2C. So if I can calculate the area of C, I can come back and plug it into this equation, and that will give me A plus B, which is the area of the shaded region, and I'll be done with the question. So that's what we will concentrate on, trying to find the value of C. So here is my diagram, and what I'm going to do is extend this line AD like that, and extend EH like this. And I can call that point P, where they intersect right there, this point right there. Okay, so in this triangle, this is a right angle since it is just that original rectangle shifted a little bit. So if I can figure out the area of two triangles, I'll be done with the question. The first triangle, of course, is the big one, and the second triangle is the small one. All right, so here we go. Remember, this is C. So C is going to be 1/2 base times height. And the base is basically EP, and the height is from here to here, which is AE. But AE is the same as AB, and that was equal to 12. So AE is also 12. So there we go. And then we have to subtract from that this tiny triangle. So that is minus 1/2 base, which I can refer to as this guy, DP, and times the height, which is right here, DH. Now we need to label some angles. They told us in the question that this is 30 degrees. So that means this is 60 degrees. We know this is 90. And therefore this angle in here will be 30 degrees. I'll just write that over there, 30 degrees. Okay, so this is once again a 30, 60, 90 triangle, and we know that the ratio of the sides are 1, 2, and √3. So to figure out the value, the numerical value of EP, I can use the ratio. EP over AE is √3 over 1. So EP over AE, which is 12, is √3 over 1. So therefore, EP is equal to √3 times 12. So I'll put that in there. We've got 12 √3 times 12. And this, of course, stays the same. Now we're going to look at this small triangle right here. That small triangle, this is 90 degrees, correct? And this, therefore, is 60 degrees. So again, we've got a 30, 60, 90 triangle with the ratios of 1, 2, and √3, like that, for this triangle right here, DPH. So therefore, if we use the same ratios, DP over DH is equal to √3 over 1, like that. So we can isolate for either variable. DH can be √3 DP over √3. And in a very similar way, we can get a relationship between DP and HP with that same triangle. It's √3 over 2. So that means that HP is 2DP over √3. All right. So at this point, there's one additional line I want to draw in this question, and that is a line from A to H. If I do that, I can come up with a very helpful Pythagorean relationship. That is AE squared plus EH squared is equal to this AH that I just drew. But AH is also equal to, if you look at the other triangle, AD squared plus DH squared, right? So that's going to help us solve for the value of DP, this one right here. So let's plug all this in. AE is 12. EH is going to be the full from here to here, EP, which we just figured out was 12 √3, minus HP, correct? And HP we just figured out right here, minus 2 DP over √3, all squared, and that is equal to AD, which we know is 18 squared, AD squared, plus DH squared, and I can use this. So that gives me DP over √3, all squared. And this will help us solve for DP. So instead of writing DP every time, I'm just going to call it X. And I think that will help us out. So here we go. We got some algebra to do here. 144 plus 12 root 3 minus 2x over root 3 all squared is equal to 324 plus x over root 3 all squared. Okay, bring everything to one side, put all the numbers on one side, you get 180 over here, and if you bring all the x's over, you get 12 root 3 minus 2x over root 3 all squared minus x over root 3 all squared. Expanding, you get the following. I just actually factored it rather than expanding it. It's easier to do it because this is sort of like a squared minus b squared, and that is a minus b, a plus b, like that. So this is what I get, and this allows me to very quickly solve. This just becomes 12 root 3 minus x over root 3, and this becomes 12 root 3 minus 3x over root 3, and that is equal to 180. And this becomes 432 minus 36x minus 12x plus x squared. And that's equal to 180. Put everything on one side and simplify, and you get this expression is equal to 0. And this factors, this gives me x, 42, and 6, negative, negative. So x is either 6 or 42. Now going back to the diagram, x obviously can't be 42, because what does x represent? It represented dp. So it's just that small distance. So x equal to 6 is what makes the most sense. So we are almost done. We just have to put in our values for dp right here, which is 6. And dh, which is the other one, we can figure out from this equation right here. dh is going to be basically dp over root 3, which is 6 over root 3. Like that. So solving here, we've got basically the good news is that we can figure out an actual decimal. We don't have to worry about roots and all that. So the first part here is going to be approximately 124.7, and the second part is approximately 10.39, and if you do that, you get 114.317. And remember, our shaded area was a plus b, and it's 432 minus 2c. So it would be 432 minus 2 times what I just figured out for c, which is 114.37. And if you do the math, you get 203.36. And 203.36 is closest to choice C for number 23. In the diagram, P, Q, and R lie on a circle with center O and radius 12. The point S lies on OR. If POR is 135 degrees, the area of the trapezoid OPQS is closest to. Well, let's cut up this diagram a little bit. I'm going to draw a line like that, that's perpendicular, and then a line like that, that's diagonal, so this is perpendicular. Alright, so the good news is that when you do that, you are able to cut this into 3 equal triangles. All of these are equal. And you say, well, how do you know that? How do you know for sure that they're equal? Well, that's where the angles come into play, right? And also the sides, not just the angles. So, for example, this was 135 degrees, and if I made this into a right angle, which I did, that means this angle in here is 45. It's 135 minus 90. So this was a right angle, that's 90, so therefore this is 45. So that means this side and this side are the same. And then this side right here is the radius of the circle, which they told me is 12. And in a very similar way, you can do that for all the other triangles. For example, this is also the radius because O is the center, and then Q is on the circle. So that OQ is a radius, so I can label that 12. And in a very similar way, since that's just a diagonal, this is going to be 45 degrees, that angle in there. And then since this is 90, this is 45 degrees right here. And then the identical kind of story holds true for that triangle. 45, 45, and 90. So this is again isosceles, so that is equal to that in terms of the length. All right? So since this side is the same as that side, all of those sides that I have drawn this symbol are all equal. Okay? So I hope that makes perfect sense. And we also know that this side is parallel to that since we have right angles here. So all we really have to do is find the area of one of these triangles and then multiply it by 3, and we've got the area of OPQS. So OPQS will basically just be 3 times the area of one of those triangles. So I'll just write a triangle right there. Okay, so how do we figure out the area of the triangle? Well, I will label this side x, and this side, of course, therefore is x also, since it is equal. And then just use Pythagoras on that triangle to figure out x. So we have x squared plus x squared is equal to 12 squared. So 2x squared is equal to 144. X squared is equal to 72, and therefore x is equal to the root of 72. So 3 times the triangle, well, one triangle is 1/2 base times height. The base is x, the height is x. So this is 3 over 2 x squared. Well, x squared I just got was 72. So it's 3 over 2 times 72, and that is 108. Yeah. So number 23, the answer is C. 24, the answer is E. In the rectangle WXYZ, the parallelogram PQRS is formed as shown. The segment PT is perpendicular to SR. The length of ST is. They want you to find the length of that small segment ST. Okay, well, several ways of doing this question here, but one way is just to look at the areas. The total area, TA, of the entire big rectangle, we can easily figure out. Length times width. The length is 3 plus 12. Those dimensions have been given. And the width is 4 plus 5. So very quickly, we get this is what? The 15 times 9. And that is 135. So that is the area of the full rectangle, the big one. Now I want to concentrate on the area of that parallelogram. Well, that is PQRS, and the area of the parallelogram is going to be the total area minus these little triangles. So if I take the total area and subtract that triangle, this triangle, this triangle, and this triangle, I'll get what's left, which is the PQRS. So total area minus the 4 triangles. So this triangle and this triangle are the same. So it's really 2 times those 1/2 base times height, since they have both the same dimensions. And then this triangle and this triangle are also the same. So instead of subtracting them individually, I can just combine them. 2 times 1/2 base times height, which is 12 times 5. Well, total area I just got was 135, and this looks like 12 and 60. So 135 minus 12 minus 60, and that is 63. So that is my area of PQRS. Now, the area of PQRS can be calculated by length times width, or length times height. This is the length, and this is the height, since PT is perpendicular. PT is perpendicular, and therefore it can be used as the height. So PQRS, the area, is PQ, which is the length, times PT, which is that height, since it's perpendicular to SR. Well, PQRS we know is 63. PT, we don't know that. That is something we obviously will need to figure out. And PQ, we don't know right now, but I can figure out PQ pretty easily using Pythagoras, using this triangle right here. So PQ squared is 12 squared plus 5 squared. And that's 144 plus 25. And that's 169. So take the square root to get PQ, and that's 13. So 13 goes here. So that means PT is 63 over 13. But they don't want PT, they want you to find ST. ST is right here. Well, that shouldn't be a problem. I can use that triangle in the Pythagorean relationship. So my final step, I've got PT squared plus ST squared is equal to PS squared. Now PS, we haven't calculated yet, but we can do that easily using Pythagoras. Some of you even remember what that is. If one side is 3 and the other side is 4, what is the hypotenuse? But just in case you didn't, we can do it really quickly. 3 squared plus 4 squared is equal to PS squared. That means this is 9 plus 16, which is 25. 25 is PS squared, so PS must be 5. So there we go. So PS squared is going to be 25. And then PT we just figured out was 63 over 13 squared, and then ST squared. So ST squared is going to be 25 minus 63 over 13, all squared, like that. Okay? And you can do this in fractions or you can do it in decimals. It doesn't matter. In the end, as long as you choose the right answer, that's all that matters. I did it in decimals, actually, and I get ST squared to be 1.5147. And then if you take the square root, I got ST is equal to 1.23 approximately. And of all the answer choices, the one that matches 1.23 is choice D, 16 over 13. If you did this in terms of fractions, you would get exactly 16 over 13. It's up to you, whichever way you feel most comfortable. So number 20.